now, guys. The diagram below, let's read together. After 2, 1, 2. Semicircle is diameter AC. Let's read together. D is a point on the circumference, and AB and BC 8.2 centimeters. Good. So based on that, looking at this shape on the inside, what shape is this? ABC. A triangle. But from today you should know what type of triangle. Is an isosceles. So you should be quiet. Why is it an isosceles triangle? Somebody tell me. The two AB, use the names of the lines. AB and BC are identical. They are the same. Remember though, isosceles does not only deal with sides, it deals with angles as well. That means that side with this angle, this side with this angle, this angle and this angle, this side and this side will be equal. So what number should I put here? 8.2 centimeters. Good. State the geometrical name of the line AB. That is something you just need to know. When a line goes from A to C on a circle, cuts it in half, cut the circle in half, what do you call that line, A to C? A diameter. Half of that diameter is called what? A radius. So 2 radii, so the radius, two radii, the plural of a radius is radii, gives you a diameter. Once the 2 radii is a straight line. But you can have 2 radii, but they're not straight lines. For example, something like this. That's 2 radii, but that's not a straight line. Okay, you understand? So the 2 radii forms a straight line. It can give you something called a diameter. Very good. Now, state the geometrical name of the line AB. What do you call AB? Something you need to know. A chord. How do you spell the chord? Good. C-H-O-R-D. That's C-O-R-D. That's a wire used for a mic. Okay? The chord. These are called chords. So example of chord AB and BC. Now, what is the definition of a chord? What's the definition of a chord? A straight line that goes from circumference to circumference. But it does not have to go through the center. That means the diameter is a special type of chord. The diameter goes from circumference to circumference, but it goes through what? The middle. But this is a chord as well. I'm going from circumference to circumference, but it's not going through the center, the middle, okay? So, when a chord goes through the center, from circumference to circumference, it's called diameter. But when it does not go to the center, it goes from anywhere in the circumference to the circumference, then it's simply a chord. A chord also cuts a circle into minor, major. I'm missing a word, I leave off a word. Minor what? Big with S. No, I said segment. Minor, segment, and major segment. You think about it now. When you're cutting cake, you cut cake like that? No. We don't normally cut cake like that. But you can't cut a circular cake like that, eh? And you cut it like that, and then you just cut it like that, you end up with dices. But normally when we cut the cake, we cut it like what? Like this. Right? Right? Even a pizza or a pie, you cut it like this. This now is considered a minor what? Somebody call the word this way along. Sector. And this is the major sector. So the difference between segment and sector is in the shape of what? Because S again. When you go to buy a pizza, you cut it up into what? Slices. So a sector and a slice is the same thing. You got a big Pac-Man slice, or you got the slice that they'll give you for how much Domino slice a pizza for Domino is? Well, a $5 slice of pizza. You understand? So sectors is like slices. Remember that, write those words. But segment is different. Segment is when a card cuts a circle, but it don't have to be in a semicircle because it's not going to the center. If you went to the center, then you cut the circle into 2 equal halves. But a sector now is like a slice. Okay? So there's major segment, minor sector, major sector. Okay? These are things that you need to know. The question is, state the geometrical name of the line AB. Oh, we don't answer that, sorry. The next question is a card. We don't answer that. It's a card. The next question.
Find the value of the radius of the circle.
Good. So the radius will be this. Would the radius be AB? Would the radius be AB?
No.
No. What's the radius up here? What's the radius there? Okay. You're lucky. You get it.
Half of AC.
So using numbers or using letters that are given to you.
Half of AC.
Half of AC. Whether the first half, A to O, now we call the center O, or O to what? C. Those will be the radii. I can't say radiuses, radii. Understand? Good. So let's say to find what? This to here. Now, before we find that, and there's a triangle in here, something you need to know. When a triangle is formed in a semicircle, I gave you this, I think, last class. Look at that. Look at that.
When the angle is 90 degrees.
Right. Whenever a triangle is found, any type of triangle is found within a semicircle, but one of the arms of the triangle is the diameter. Once one of the arms is the diameter, no matter if this is short and this is long, the angle formed at the circumference will always be 90 degrees. Try to draw that in your books, please. That is something you need to know. This comes from something called circle theorem. Anybody did this recently in school? Yeah. Right, circle theorem. This might be the second theorem, maybe. Right? And how it forms? How it forms is that if here is 180 degrees, the angle at the circumference will be half. You understand? So it comes from this theory. If this is quadratic circle, quadratic circle. If I have what are you trying to get, man? Oh yes, that's what I remember. Let me come back to that. I'm going to come back to that. Hold a second. This is what you call a diameter, and then the angle that is formed on the circumference is 90. And you know a straight line will be 180 degrees. Half of 180 is 90. This is the same. If I take the straight line and then I bring it down this way, and then bring it down this way, so that now it's down this way and down this way. This is now 120. Half of 120 is what? 60. You see that? So these two theorems are exactly the same, but this is a special case where it's formed from a diameter. Half of 180 is 90. So if this was if this was 150 degrees, what will it here be? 75. You see that? So here is double the angle of the circumference, or the angle of the circumference is what? Half of the angle formed by the center. So you need to know that. But guess what? They're still the same. The angle at the circumference is half the angle at the center. So if that is true, if this is 180, that has to be half of it, 90. But they put it as a special case for itself that you need to remember. So anytime you see a triangle formed in half a semicircle, the angle up here is 90. Even if it is formed this way. No matter how we shift the triangle, you're gonna have be what? 90. No matter how you shift the triangle, it will be 90. I'll show you next time I'm gonna show you that. These circle frames you have to learn, but for now we're not going to deal with these two. Pause it. It's still half at the circumference, even if it's a reflex angle. This angle here, then, and if you go home so long till you think you all the juice. So this angle here is then 90 degrees. So you need to know that, okay? Everybody understand? It is half of 180. Now we move it. What is it we're looking for again now?
The value of the radius.
Good. And you said the radius is either over here or over here. Now, what can we do? Something, so I'm missing something from here. 8.2. What have we realized about this?
You gave it two sides?
You got two sides. We got two sides. And what type of triangle it is now? It's isosceles, but we found out this isosceles triangle is also another type of triangle. Very good. What are we saying here, guys? Let's go. The triangle has two names now. It's an isosceles. Why is it isosceles?
Two sides
are equal, which means two angles are equal. But also we just found out that the angle at the top is 90. So it is also a right angle triangle. And guess what? Whenever we have a right angle triangle, two processes can now work. Two processes can work, which are Pythagoras or trigonometry. But would you use trigonometry for this? No, but there is no stipulated angle beyond the
right angle.
Right angle. So then clearly in this case we head to what? Straight to Pythagoras. That's what you guys, right? Pythagoras theorem. Now you should take out the triangle and orient it based on how your eyes would properly see it. That's how you know that the things look that way. So you can do it, so redraw it. So let's again recap. We found out that it's an isosceles triangle. What identifying mark lets you know is an isosceles triangle, by the way? The lines or the strokes. So either they did not say it's isosceles, by virtue of these lines being here, you know it's isosceles, okay? Secondly, we just found out that it is a right angle triangle. So based on that, we oriented it this way. B is here, B is here. So AB is 8.2, AB is 8.2, BC is 8.2. So where is the hypotenuse? Which side is the hypotenuse?
AC.
AC is the hypotenuse. So you start doing that. Okay? And all the other sides is arbitrary. You could have now, in like trigonometry, you have to worry about the angle to make the other side opposite or adjacent. Once you have that, h squared equals b squared plus c squared. Well, we do not know what a squared be. H squared be, so you have ac squared What is B squared? 8.2 squared plus 8.2 squared. What is 8.2 squared, guys? Calculators. Listen. 100 and the searches 134.48. It stops at 48. Everybody, anything is better than 48?
Yeah.
Huh? Somebody say yeah. Anything is better than 48, guys? 8.2 times 8.2, guys.
No, you do it again.
Yes, this okay, it can be 134 for sure because 8 times 8 is 64.
But when you click them, you don't get 134.
Oh, he gave me the total.
He gave you the total 134.
Oh, okay.
I wonder you know me, so that.
Okay, 67 point what is it?
Yeah, we can calculate
Plus 67. Okay, 0.24. And then 134.48. What? What's the square root of that now?
11.59655.
I'll give you a secret. When this got to one decimal place, then this side must also be to what? One decimal place. We agree? Because what would you get 8.2, 8.2, give 23 decimal place for this? Right? 11 point what? Guys, I'm hearing 11 point what?
11.6.
6 what?
Oh, you want 11.6?
The 11.6 at the end, the math that I do.
Oh, so it was 6 there already. Okay.
Yeah.
11.6 centimeters. Awesome. Well, what I asked you for? What the question I asked you for?
The value of the radius.
The value of the radius. I want that value to be just fine. The diameter. Actually, what do you think of that? You think of it,
No?
I know, but it's very close. It's very close. We found the diameter. So what's the radius? Yes, tell me. Half of it. Half of
11.6.
11.6 is what? 2011 goes 5 times. 2016 goes 5.8, yes. So here is 5.8 centimeters. Yeah? What's that? How much size this have? How much size this have? What normally the angle for here? I stop whispering man. Good. So we have interior angles. We have 3 times 60 equals 180. We have 4 times 90. No. 4 nines are 36, so 360 degrees. Good. So now we have BAP. So man, look up for me for a pentagon. What is the sum of the interior angles? Man, look it up on the internet quick. Google it. Chat GPT.
Where's some finding interior angles?
You said 160? No. Wait, which day? I'm going down the line. I'm going to the line. The total is what? 540, right? And how much size is here? 5, right? Right? So 540 divided by 5. Tell me how much the angle will be inside here. I don't see it here. I'll tell you. 108. So each of these will be 108. But see that? We had 60, we had what? 90, we have what? 108. 108, 540. But let's look at this now. These are different colors. What's the difference between 180 and 360?
180.
The difference is
180.
180. That's half of that. What's the difference between 360 and 540?
180.
Yeah.
180.
180 degrees. Right? Good. So you realize something. As the sides increase, 3 sides, 180, 4 sides, they add on 180, 5 sides, they add on 180 again. But this is the 6 side of me, just quickly. 6 side, a hexagon now.
Yeah, add 180.
720.
So it'll be 720? And then this space bar. 720, right? What the angle of the interior angle will be?
120. 120.
Is 120, are you sure?
Yeah.
You see, 6 times
60 20.
6 zeros are 0, 6 twos are 12, cover the 1, 6 was, yes, okay, good. So each of these inside will be what? 120. Sorry. 120, 120. Look at the angles now. This was 60, this is what? This was,
90.
this is what? 108, this is what?
120.
120. What is happening to the angle on the inside?
Increasing.
Is increasing. You got 60, 90, 108, 120, 7 gonna be a bigger angle on the inside. It's coming more obtuse, you realize? This is a acute angle, this is the right angle, this is an obtuse angle, this is definitely an obtuse angle. Catch the angle inside getting what? Each of them getting what? Bigger, you understand? Right. So this is the formula. Sum of interior angles. Sum of interior angles is this. S equals n minus 2 times 180 degrees. You realize that 180 come back? Remember that 180 come back? Remember 180.
You keep adding 180.
You keep adding 180 to get what? This one here, 720, right? You said 720 up here? So it'll be what? 6 times 120. Good. So that's where the 180 come from. But guess what? What is the smallest side we have? What is the smallest amount of sides we have here?
3.
3. Can they have a polygon that has 2 sides? No. So the smallest is the 3, right? So think about it then. Let's see. Let's substitute. Let's say we put 3 here. 3 minus 2 times 180. 3 minus 2 is what?
1.
So 1 times 180.
180.
But see that now? So I can find the sum of the angles for a triangle. Let's substitute the 6. Let's put back the S. N minus 2 times 180. Let's put 6 instead. S equals 6 minus 2 times 180. 6 minus 2 is what?
4.
4 times 180. That's what we probably can see there. 4 times 0. 4 times 8.
720.
22. 4 times 1 is 4 plus 3. So you're going to say 720. So what you agree that this sum of the interior angles, the 180 is because it is increasing how much times? Every time the side increase, every time a side increase by 1, the sum of the angles increase by what?
180.
180. And there is no two-sided or one-sided polygon. So the minus 2 will stop you off. You understand that? Take another formula, pause it. You could take the number of sides and divide it by the sum, right? Right, so basically is this. n minus 2 times 180 degrees over how much sides? Okay? When you don't find the sum, you divide it by how much sides? The n represents the number of sides. Let's try it out. Pick a side, pick a number.
3,
Give me the 3. Give me another number besides 3.
4.
Let's try 5. Let's try the 5. Then substitute. 5 minus 3. Before we go any further, what angle we had in the 5-sided figure? Remember? What? In the pentagon, what was the angle within
108.
inside?
108.
Huh?
108.
Was 108? Good. So we headed this to 108. Let's go. 5 sides. You take away 2. Sorry, the man can't read this. Take away 2 times 180 over what?
2. No, 5.
Over 5. So n represents the sides. We write that somewhere. N represents the sides. Good. Okay. So 5 sides. 5 take away 2 is what?
3.
Somebody work out 3 times 180 for me quickly. 3 times 0 is 0. 540, right? And 540 divided by 5. 108 degrees. So you see that? So this is to find the sum. You realize this is on top? Everybody realize that? I realize that this formula is on top.
Yes.
So to find the sum is this. To find the angle within, you simply divide everything by the number of sides. You see that? Good. So here the question I'm asking you now. Each interior angle of a regular polygon is 160. So we're going to use this formula here. I'm going to write it back. N minus 2 times 180 divided by n equals 160 degrees. You see that? Good. Let us cross multiply. We'll cross multiply. What do you mean by cross multiply? Okay, we said cross multiply. We said it a different way. You figure it for the camera. Yeah. Watch. Let's transpose to leave this by itself. We want n minus 2 close bracket and 180 on the left side by itself. So what we're going to do? N minus 2, guys, what we're going to do?
160 multiplied by
160
by n.
times
N.
n. We never got the times, guys. You know this 160 n. You understand?
Okay.
Good. So the divide by n became times by n on the other side. You see that?
Yes.
Good. So now let's do the distributive law. We do the distributive law. The distributive law. Somebody help me.
180 n
180 n
and
minus
360
minus 360 equals 160 n. Can we group now? Let's group and let's make things positive. Remember we want a negative now here. So what do you think we could do to group? 180 n minus 160 n equals 360. Which gives you what now? 20 n 360
And n equals
n equals
360 divided by 20.
good. So you realize that the long method I gave you when I take you long, because guess what? How much size this polygon got? The polygon got 18 sides. I can't even draw that. Who could draw 18 side polygon? Come help me here, please. 61 kilo, you see? You guys see the purpose of algebra now? You see how algebra helped us? Because we go the long way. Keep going, keep dividing, keep going, and take our morning. Algebra knock off everything one time. You guys think you do this in exams?
Yeah, practice.
Good. So it's a reflection in the line x equals -1. Right? Again, the x numbers go from left to right, from west to east. Let's go. -6, -5, -4. Let's go. -3, -2. And they say what? X equals what? X equals -1. So when you find that, it's the vertical line in which you're gonna highlight. You're not gonna, oh, x equals -1, and you highlight the x-axis again. These vertical lines are following what? These what? Numbers, you realize?
Yes.
So this is the line of reflection. You go all the way down. Also, the line, the mirror line is also the line
Symmetry.
of symmetry. Anybody know what the symmetry means? The line of symmetry means if you fold something, it will fold exactly. So if I fold my arms, my thumb touch my thumb, the index touch my index, the middle finger touch my middle finger. I am symmetrical that way. Your left nostril supposed to match your right nostril if you flip it. Okay? Your left side of your face, if you peel it off and come over, it's supposed to land perfectly on the right side. That's what symmetry is. You understand? This is not symmetry. Something like this is not. I don't know if black marker does know. What do you do? This is not a line of symmetry. If I cut this like this, if I fold this over here, it's gonna land where nothing is. You understand? But take this and fold it over here, you're gonna land where nothing is. But this now, this square has two lines of symmetry. Like a handkerchief. I can fold this way. I can fold it upward, you understand? And if it's perfect, if it's a square, I think it's a square, I think you can fold diagonal as well. So there will be 3 lines of symmetry. You understand? Some shapes got more than 1 line of symmetry, some don't. Okay? A vase, you see a vase like this. Why? If you cut it like that, but if you cut it like this, will you have a line of symmetry? Maybe.
Yeah.
Like this line and that, last line and that, yes. Okay? But you can't do it this way though. You can't do it diagonal.
No, it will never work.
Right. So, good. Remember, with the mirror line, reflection, there is some features of reflection that you need to know.
Because of people that reflection.
Yes. If a mirror is in front of me and my nose is 2 feet from the mirror, in the mirror, my nose looks like what? 2 feet away. Okay? If my hand is behind me and it's pointing is 3 feet away, then in the mirror my hand looks like it's at what? 3 feet away. So then in a reflection, you need to count the distance from the mirror line. You can count it by the boxes. How far it is? 2. That means, let's call it like A, B, C, D. It will be the letters of what? C will be what? C will be what? 2 boxes away. Ever see that? B is how much? 1, 2, 3. So, 1, 2, 3. This is B. Be quiet. You can connect that now. You remember that. From that is basically rudimentary. How far is A away? 1, 2, 3, 4. So 1, 2, 3, 4. And you don't know you're gonna be here, back, back, back. If I call it something, if I call it A, if I call it A point. Okay, what's that? So C was the closest. So on the other side, C has to also be the closest. D was the farther away than C. So over the other side, D has to be far away from the mirror line. Okay? Everybody confused? Let me was following, I was following. Let's go again. We go from here. This is the mirror line. Mirror line. Hold on. How far is here from the mirror line based on boxes? 1, 2. So over the other side of the mirror is going to be what? 1, 2. How far is this from the line? 1, 2. So let's go. The 3. 1, 2, 3. So 1, 2, 3. This is the 4 now. 1, 2, 3, 4. So 1, 2, 3, 4. This is what? 1, 2, 3, 4. So 1, 2, 3, 4. And you can see the shape look alike, it look the same. It does not look like what? In what? You know what? It's flipped or reflected. Do that in your books. I read the manual with you. I'm just showing you. I taught you this. Translation is the only one that uses what?
Plus.
Plus. T plus P. But in this case, let's use A, that is A. T plus A equals what? A image, which is the image, that means the image of A. You understand? What's the translation? What's the translation? 4,
7.
negative 7. Give me the points here, guys. Give me the points here. What do you call this? Guys, everybody.
Negative 5.
Negative 5, 2. Right, negative 5, 2. Next one.
Negative 3, 2.
Let's go in order.
Up. Negative 5, 4.
Next.
Negative 4, 4.
Why only 2 people are tripping down talking in here? Guys, let us count on the coordinates. Negative 4, 4. And then what the last one is?
Negative 3, 2.
Negative 3, 2. So what you do, you write the translation 4 times. You can add unlike matrices. So you write it twice. Negative 4, 7. 4 times, sorry. Negative 4, 7. Negative 4, 7. Negative 4, 7. Everybody see that? Good. So now you come. Negative 4, negative 5. So now you come. Negative 4, negative 5. Don't pull the calculator.
Is there
Yeah?
4, negative 7? 4, negative 7.
It's 4, negative 7?
Yes.
Also my bad? Thank you for the correction. Make a nothing for me. So it's easier for you now, so now you come. 4, take away 5. Without in here for ornament. 4, take away 5. Class, 4, take away 5. 4, take away 5 is not 1. I always tell you, always do this. 4, take away 5. You're going to realize 5 bigger than 4. So you're missing 1. Negative 1. And then he said 5, take away 4. I said 4, take away 5. That means you're missing 1. Good. Next again. So this one going negative 1 again. 4, take away 4.
0.
0. And 4, take away 3. 1. Below. Minus 7 plus 2.
Minus 5.
Minus 7 plus 4.
Minus 3.
Minus 3.
Minus 3.
Minus 5.
Minus 5. Let's look at these coordinates now. Negative 1, negative 5. Negative 1, we are over the mirror line now, but this is different. Negative 1, negative 5. Negative 1, negative 3. 0, negative 3. And 1, negative 5. The way, this is called A double prime. The way some of you they try to do it, which is still correct, which I like, if you call right translation, but the love that translation is the only transformation that has a plus. So the translation plus A will give me A image. Okay? Now the translation says 4 negative 7, 4 negative 7. You don't press right? 4 negative 7, 4 negative 7. Plus the different points. Negative, let's count the points, guys. Class, come on. Negative 5, 2. Negative 5, 4.
Negative 4.
Negative 4, 4. Negative 3, 2. And why is it 4 and 4? Because they can't add unless you have the same order. They have to be the same size. Okay? So 4 take away 5 is negative 1. 4 take away 5 is negative 1. 4 take away 4 is obviously 0. 4 take away 3 is 1. Negative 7 plus 2 is negative 5. Negative 7 plus 4 is negative 3. Negative 7 plus 4 is negative 3. And lastly, I'm talking guys, negative 7 plus 2 is negative 5. When we plot these, negative 1, negative 5, negative 1, negative 3, 0, negative 3, and 1, negative 5. Okay? Also, you can do it the longer way, which is, as we saw with these red things here. You can actually count and say, well, this starts it off. So you go 4 to the right, 1, 2, 3, 4 to the right, and then what down? What up down?
7.
Good. 1, 2, 3, 4, 5, 6, 7. This is the front, so that has to be the front. You could do this one as well. 1, 2, 3, 4, down 7. 1, 2, 3, 4, 5, 6, bam, 7. Okay? And you can use 1 to back check the other. God bless you. Thank you.